Welcome to TechChin. Today I'm here to share basic knowledge of TCP, which is Transmission Control Protocol, and we are going to use this TCP protocol in transport layer. Let's go into the topic. This is the basic agenda of the TCP. So, what is TCP and why it is designed, where it is placed in data transfer, and what is the use of TCP header and what are the known protocols that has been used, and the last but not least, what are the benefits of it. The first thing we are going to discuss what is TCP, and the second one why it is designed. So as we know, TCP, which is a transmission control protocol and mainly used in transport layer of OSI, which is the fourth layer of the OSI model. So why we are using TCP? For reliable communication, and once we send messages or data by using the TCP protocol, then we will get the acknowledgement for each and every message that we send from our end. That is the use of TCP. So for reliable communication, we are using the TCP protocol. Okay. So we can also call it as Internet Protocol, Transmission Control Protocol, or Reliable Protocol. What it do first, it established a connection between the sender and receiver. Then it will transmit the data. The size of the TCP header is 20 bytes, which is the minimum size, and maximum it go up to 60 bytes. Why it is 60 bytes? It depends upon the options field that is added in the TCP header. Minimum is 20 bytes and maximum is 60 bytes. So what information it have? It wraps the data packet with the header information. Okay. And then why it is designed? As I told you, for successful delivery as well as the secure transmission, we are using the TCP connection. Okay. This is how the data wraps along with the header information. Each layer have header information when it passes through the next layer. And where this TCP layer information placed, it placed in the transport layer. And why we use this TCP header? So on top of IP protocol, we use the TCP header information while sending the data. What is the main use of this TCP header means? It solves the problems that arise on uh, packet transfer. In case if you lost any packet, or if it is out of order, or if you see any duplicate packets, or if it might corrupt while sending the data, this TCP will resend the information. I mean, this TCP will solve these kind of problems that arise while transmit the data. Okay. These three are the known protocols of TCP: IP, ARP, and ICMP. The main benefits of TCP are, which is a connection-oriented protocol that we already know. It's for reliable connectivity, and due to this reliable mechanism, we can deal with the packets of any lost, delayed, or duplicate packets. And we can also have timeout mechanism where we can retransmit the packets to the end user. And for each and every packet, there is an acknowledgement has been sent back to the sender. And for streaming the data transfer, we can use the SYN bed. And for flow control, we can use the acknowledgement bed. So we already discussed in the previous slide, it have a mechanism to solve the problems that arise on packet-based messaging. This is the packet format. This IP packet have IP header as well as the IP data. From the IP data, again, it will be divided into header and data. If you use the TCP, it have TCP header and data. If you use UDP, it have UDP header and data information. This is how TCP header looks like. And the first two fields are source port and destination port. These are the port numbers of the source and the port number of the destination. This is not the system's port number. This will be the application port number. that used on the sender and receiver. And sequence number, it rearranges the packets on the destination side. Acknowledgement number, it acknowledges the received packets and also request for the uh, next packet info from the sender side. Header length, this is the actual length where the data starts from. Reserved bit, this will be always set to 0 and used for the future use. And code bit, there are 6 pointers like urgent pointer, sin, acknowledgement, reset, and push, fin. So we can discuss this in the next slide. And window, this is the bytes of information that we are sending while transferring the data. So the window size should be set by the receiver uh, to allow the maximum byte information that it receives from their end. Checksum, it is like CRC. So we have seen in the Ethernet header where we can see CRC for any errors for checksum. Okay, and urgent pointer. So to use this urgent pointer here, urgent bit should be set to 1, then only the information has been sent immediately. Options, these are optional and TCP header size varies depends upon the options field. Okay. From now on, we are going to discuss the fields in TCP header. So source port, destination port, those are the ports belongs to sender and receiver. It's not the sender system or device port number. It belongs to the application port number and it varies from 0 to 65535. And this is the range of port numbers, well-known ports, register port and dynamic port. And well-known ports belongs to uh, HTTP, like application port numbers. So HTTP, HTTPS, FTP, FTP, SSH, Telnet, POP. These belongs to the well-known port numbers. And sequence number, it is used to put the data in the correct format in case if any missed packets or any missed segment that can be retransmit by using the sequence number. Acknowledgement, it is given by the receiver and also request for the new segment. By requesting segment number plus 1, it means that I received the current segment, so looking for the next segment. Suppose my segment number is 2, I send from the sender side and receiver respond to the sender as sequence number 3. Says that I have received the segment number 2 and looking for the segment number 3. Can you send me the segment number 3? This is the request that is sent from the receiver. Header length, it indicates the actual data that begins on the TCP header. And result, it always set to 0 and used for future purpose. So we will not use the reserved bit. These are the 6 pointers, control bits in the TCP header, urgent pointer and acknowledgement, push, sorry, I have mentioned it wrongly, push bit, reset bit, synchronization and pin. So what is the urgent pointer? If you want to send any data urgently on priority basis, like if you have a voice, it always have a high priority. Then you can use this urgent pointer. It should be set to 1. Then only urgent pointer will works in the TCP header. Acknowledgement, it always set to 1 when it gives the acknowledgement back to the sender. Push, if you want to push the data, you don't want to wait until the entire TCP segment fills, so you can put the push bit. Like what it do, it sends immediately. Reset, if you want to reset the connection, the reset is different and fin is different. So both are used for the termination, reset and fin. But what reset do? If you want to uh, do the termination immediately, like if your application is stuck, So this is not the normal way to terminate your TCP connection. If any application is stuck, what we do, we always restart the application. Or we can immediately close the application from the task manager and we can open it again. That is the reset. And synchronization, it is used for the synchronize the sequence numbers. So for the initial way of three-way handshake, we can use the SYN bit first, then acknowledgement, then SYN plus ACK, then termination. So FIN, this is the normal way of the termination. Both parties can agree that we are going to terminate the session. This is the normal method. Like you log in into your application by your username and password, you have done the logout properly. That is called the finish. Terminate the connection. In case if your application is stuck, then you closed immediately and again you opened it, or else you closed immediately. That is called a reset, where you terminate the connection from your end. Okay. And the window, as we discussed, the bytes of information that we are sending. So first, receiver can tell the sender how much amount of byte information that uh, it it acknowledged. Okay. So according to the receiver information, sender sends the byte information. And checksum, it is like CRC check in the Ethernet header. So in TCP we used a checksum to check the integrity of the TCP header. And urgent pointer, so if you want to send the data immediately, then urgent bit should be set to 1, then only urgent pointer should be enabled. Otherwise, if you put the urgent pointer as 1, it won't send the data immediately. This field will also be set to 1. Options field, it varies from 40 bytes because the TCP header info varies from 20 to 60 bytes. So minimum is 20 bytes. So this option field can be varied. This is the 0 or 32-bit information. Okay. And this is how the TCP header information looks in the Wireshark. So this is the source port of the sender and destination port of the receiver is 23. 23 belongs to telnet connection. Means they are using this TCP connection for telnet. They are doing the remote session of their application, their system. This is the source port number 41417. Might be it belongs to the client PC. They are going to take the remote session for that. And sequence number in Wireshark, it always starts with 0, but in production environment, it varies. Acknowledgement number is initially it's 0, and you can see the flags, say reserved and CWR, urgent pointer, acknowledgement, push reset, everything set to 0, and synchronization, it's going to start the connection. Means it's going to establish the three-way handshake. Once the connection is established, then they are going to send the data. And fin bit will also 0, and window size is 4121. This size is always in the form of bytes. Checksum and urgent pointer, this is not the urgent data that we are going to send, so it kept it as 0. So this is not the voice information. Options field, that's all. This is how TCP header looks, and this is the maximum information. Thank you so much for watching, and if you like this video, please do like, share and subscribe for the more upcoming videos. Thank you. See you again.